Welcome to another video. In this video, I'm going to be building a MS20 style high pass, low pass filter. And what this filter will do is in the high pass setting, it will allow the high frequencies of the waveform to pass unattenuated based on your cutoff point. And for the low pass, the same respectively. Our ears are used to hearing a lot of the high frequencies scrubbed out of things just because the waves going through the air and bouncing off of everything, a little bit of the chirp is knocked off of everything that we hear naturally. So it can help to build a more natural sound, a richer sound, or it can really mess the sounds up completely. Now this project was originally designed by Clacktronics for the circuit diagram, and then Sam at Look Mum No Computer decided to go ahead and do a stripboard layout interpretation of that circuit diagram and released all the information on how to build it on his Patreon. So really this is a paint by numbers type of operation. It's not going to be something that I've designed or modified. Really the only thing that I'm going to have to design myself is the behavior or the locations, I guess, of the components on the front panel. And that's always intriguing to try and build, because you don't want the wires in the way, but you don't want the wires all jammed together, so eventually you just get lost because you've got four little holes beside each other and you're not sure what they do until you've used the module for quite some time. So let's just skip on over to the soldering station and start getting this thing slapped together. So I'm going to take this opportunity for the high-speed build to kind of explain how I blew this board up twice while I was testing out the power. So the original stripboard layout was actually a circuit diagram from Clacktronics that Sam from Look Mum No Computer had so expertly converted into a stripboard layout. And taking a circuit diagram and putting it into a stripboard layout is not an easy task, and I applaud him for the time that he takes to do these projects on stripboard rather than the circuit diagrams for beginners such as myself to be able to build and put together and enjoy. Unfortunately, in the layout, he had the power and the ground routed to the same trace. And me just being in copy and paste mode rather than in thinking and designing myself mode, I just soldered them on the same rail and just kept on rocking. So I put the power and the ground on the same rail on the right side of the board, and then on the left side of the board I had just put the plus 12, the ground, and the minus 12 in the correct positions, so I thought. So when I turned it on the first time and plugged the power in, the LM13700 and the TL084 just blew up. Pow! The LM, it actually fried and it melted, and it released the magic smoke. And so I was pretty frustrated by that, and I said, what in the heck is going on? So I looked over it, and it dawned on me like, oh god, I've got the power and the ground going onto the same trace on the right side of the board. So I desoldered them and moved them back over, grabbed two new chips, put the new chips in the sockets. That's why you always use sockets. That way you don't have to desolder a 16 pin or an 8 pin or whatever the pin out happened to be, which can be pretty frustrating. So I plugged it in again. Pow! The chips blew up again. I said, geez, what is going on now? So I had transposed a error on the left side of the board where I made it minus 12, plus 12, and ground. And when I installed the chips again, just as I was about to plug it in, I realized, wait a minute, I copied the repair on the right side to my incorrect transposed position on the left side. So I managed to not blow a third set of chips, and when I plugged it in, everything seemed to power up okay, but whenever I would get so far into it, it would short out, and one of the LEDs didn't even work. So I had the one of the LEDs was flipped around because the LEDs had to be in reverse polarity to each other, and that was something that I did not do. So I desoldered that LED. It was dead, and put a new one in the correct position, turned it on, and everything worked out great this time around. But it can be extremely frustrating on one of those things where you have stared at a board of tiny components for what could very well be 2, 3, 4, 5 hours, and when you believe that you're on the home stretch, you just kind of like, oh, I'll just slam these power wires in and get to her cracking. But unfortunately, I managed to blow up. It was only about $5 worth of chips, but when you're building these things for yourself, cost is kind of an issue, and just kind of throwing $5 in the wind because I forgot to double, triple, quadruple check the placements of those power wires was fairly frustrating. Now, the product, it ended up working, and it didn't blow anything up when I finally plugged it in, but that was really the only roadblock that came to me during this build, was just transposing the wires and then compounding that error while fixing another error and then almost blowing it up a third time. So it was a bit of an adventure, but the funny thing is placing the 30 or 40 discrete components on the board, none of them are in the wrong place. It was just when I went to attach the power cords, I just got a little lazy or a little ahead of myself and just kind of tossed them in where I thought they made sense, and I was incorrect. So with this build complete, let's just pop on over to the next segment.
So here is the front panel complete. So I've got the two 100K potentiometers, the 3 jacks, the 2 LEDs, the DP-DT switch, which is on this way and on that way, and the 47 or 4.7K potentiometer. Now this potentiometer is a bit scratchy. It sounds a bit fucked up. I'm not exactly sure why. It has such a grindy sound to it, but this is unfortunately the only size that I could reasonably find. So it's a pretty big potentiometer, and it takes up a huge part of the footprint here. So I've just got 3 mounting holes, which will correspond to 3 holes on the board. I'll have the board facing like this. So now I just have to run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 wires from this board to this panel. 25 wires. Oy, oy, oy. It's pretty late at night, and I really don't think that I'm going to get all of those wires done, because even if it just takes me, you know, a minute per wire, that's still a half an hour, and it's pretty late. But I'm gonna give it as much as I can, and perhaps pick up the high speed tomorrow. Now, when it comes to the diagram that I have, the diagram is all pots facing front. So I'm going to have to invert everything that I'm thinking when I'm putting this thing together, which is kind of a trip. So hopefully I can get everything put on here in a way that works, and it won't drive me absolutely batshit bananas to do it. So I think I'm going to start off with wires that are, you know, about that long, for the main connection points, just so I don't run out of wire when eventually I go to put this thing on, because I'm going to have to build it and attach all the wires from this when it's laying down, and then tuck all the wires in underneath and mount it like this. That way, if anything, you know, goes wrong with it, I can just flip the board out and take a look at the back and see if there's anything that gets burned out, rather than having to take the whole thing apart just to look at it if it's messed up. So I'm going to go ahead and start soldering these wires on everywhere.
So while I was building the front panel together, even though I specifically tried to make the wires long enough that I could flip the board over and place the board in the correct orientation, once I was done, I had made a few of the ground wires too short. So when I went to flip it over and I went to mount it with the component side in, because that was how the wires reached, I realized, oh God, I mentioned that I was going to build this thing so the wires were all long enough to put it component side out, and I ended up building it with the wires too short to the point where it had to be component side in. So I had to desolder and rearrange a bunch of wires to make the situation so the wires were long enough that I could rotate the board and orient it to the mounting holes correctly. Just one of those things where you just dig your head down and you get into something and you kind of forget everything that it is that you're trying to accomplish. So, you know, a bit of a mess up, but in the end it was easy to repair, but still frustrating to have to go through and desolder and resolder a bunch of wires, especially after I had taken the time to make sure that I had the heat shrink wrap over all of the connections. So after a really frustrating day, as you've heard during the high speed, it's a good thing that the high speed did take so long, because it gave me an opportunity to explain how everything just went so wrong during the build process. But at the end of the day, here we have our filter. So we've got the CV level, the resonance, the output, the CV level input, the input, and the cutoff. This switches for the high and the low. And here's kind of a see-through view of all of the foolishness on this side. And here's the backboard with the mounting bars, the standoffs in place. Now, because this potentiometer is so large, I had to use very tall brass standoffs, and you know, the funny thing is the brass standoffs are making up a fair portion of the cost of this build, which is just kind of funny to me to think that the little brass bars that are holding it up and the DPDT switch are some of the most expensive components to build this filter. So now that I've got one built, I have the confidence to be able to build a few more. So let's chuck this in on the rack and see what kind of funky, spacey sounds we can make with it. Well, that was fun. Getting this thing all put together was a little bit of a nightmare, and it kind of drove me friggin' crazy a couple of times. When I set the project down for that night a while back, it was actually the night before I had to string my life together to go to Evolve. And when I got back, I just, I didn't have the steady hands that I normally have. Going full bore for 4 days straight can kind of do that to you. So I let the project sit for, 2 weeks? And then picked it back up and started to build it, and just got lost in so many places and messed up in so many places, and just really did not have a good time finalizing this project and getting it together. So I'm so happy that it's done, and I'm so happy that it works, and it just, oh, thank God, because I was not looking forward to having to go through with, the meter and do continuity checks, or go through with the oscilloscope and see if everything is doing what it's supposed to, or if this capacitor isn't working, or if this resistor blew, or whatever. So, it works, it works, it works, it works, it works. So thank you for coming on this journey with me. This has been one of the more difficult projects to slam together, just because of how many times my brain got fried by my mistakes and other mistakes, and just so thank you for watching, and I hope that you stick around for my next project. It's going to be a bit of an audacious one. Actually, I'm not sure. I may just do the build video of a DIY setup that I purchased to build together myself. Or depending on if my AliExpress order comes in on Monday or Tuesday, I may go ahead and do the big crazy project, which will be by far the most audacious project that I put together. So thank you for watching and have an awesome day. So I figured a little bonus I would just play some StarCraft. Ooh, you can see the reflection of the fact that I'm wearing no pants. Awesome. I would like you to see what the filter does to like an audio, like a voice.
Whatever path it takes, even if it doesn't see it straight away, as soon as it moves one more inch, it will see this proxy. Oh, it turns it around!
Oh wow, you turn it around. And this is actually the normal Overlord scout pattern, because if you scout that far out, you will see the middle spot for a proxy barracks very, very late. So I think what Sarah usually does is he goes, checks all the close locations, and then he goes back a little bit. So he will for sure see the SCV, but he will not always see the barracks. So in this case, the difference that it makes is that Sarah couldn't cancel the gas. So now he will have a little bit less minerals to work with and one less drone to pull.
Sarah will go down the ramp with a couple of drones and start picking away at this SCV. The SCV forced to abandon on that bunker right now. It doesn't look like the first bunker will be able to complete. Now what does Sarah need to do, Lambo?
So on this side, we're cutting out the lows.
So now it's very important that you realize that it's
And on this side, we're cutting out the highs.
the Terran could be hiding a third SCV, but it's very unlikely. So in this case, he does not want a spine. He just wants drones and you pull a lot of.
So that's just a bit of the context of how this thing works when it isn't filtering insane bleep loops. And I'm sorry for the shakiness of the video, but I've been concentrating on little tiny things all day and my hands are a little shaky. So thank you for watching and have an awesome day.